Hi everybody, so this is just a lesson to talk about the different experiments that were done to study photoelectric effect. The first one was to study the effect of changing frequency on the current. Now this was done by shining white light onto the emitter plate, and the way that the color of light was changed was by putting different filters in front of the light. And they found that for low frequencies, like colors like red, there was no current. But however, when the frequency got higher, that is towards the blue end of the spectrum, the instant light hit the emitter plate, there was a current. So that was the first one. The next one was to study the effect of frequency and intensity on the size of the current. So effect of frequency. So frequency has to do with the different colors of light, and intensity. The word intensity stands for the brightness of light on the current. So what they found was they tried to do an experiment where they changed the frequency but kept the intensity the same, and they found that changing the frequency didn't really have much of an effect on the size of the current, so long as the frequency was above a particular value, which is called the threshold frequency. The instant light hit the emitter plate, a current flowed. So this red line represents the current where the intensity of light was a particular value. Now they repeated the same experiment, but they made it brighter. Let's say for brighter light, they found that the size of the current was bigger so long as the frequency was above the threshold frequency. So you get a similar sort of graph, but a bigger current. So the size of the current depends only on the intensity of light. And the conclusion for this is because light is a stream of particles called photons, and for more intense light or brighter light, there are more photons falling on the emitter plate, and the energy of a photon is all absorbed by the electron. Okay, and this is how they escape. Now the third experiment was to study to measure the kinetic energy of the photoelectron. So the third one was measuring the kinetic energy of the emitted electrons. Now I have done a Chromecast video on explaining how this experiment was done. This is by giving the emitter plate a positive potential so that all the electrons are attracted back to the emitter plate without reaching the collector plate, and when this happens, the current becomes zero. And the energy of the photoelectrons can be calculated by Ek equals E times V, where E is the charge on the electron and V is actually the cutoff voltage. Now the cutoff voltage is the voltage at which the current becomes zero. Now just going on from this experiment, and which wasn't there in my earlier video, is if you draw a graph of the kinetic energy of the electrons against frequency. So this was done for different frequencies of light, and what they did was they changed the material of the emitter plate. So for a particular emitter plate of a certain material, they found that when they drew a graph of kinetic energy against frequency, they found that as they increased the frequency, the electrons had more kinetic energy. How do you know that? Because it took a greater cutoff voltage to stop the electrons. And so the graph looks something like this. Okay, but if you used an emitter plate of a different material, you get a similar graph, but a parallel line showing that the gradient of the graph is the same. And what you notice on this graph is that there are two intercepts. Now the intercept on the x-axis is your threshold frequency, and the intercept on the y-axis is your work function energy. So below the threshold frequency, no electrons are given out, and the work function energy is the amount of energy required to release or free the electron from the atom. And it's found that different metals had different threshold frequencies as well as work function. So that was the third experiment. Now the fourth experiment is not really given in your books, and that's why I thought I'd make this video about that. And this kind of follows on from here. And if you draw a graph of the size of the current against frequency, size of the current against voltage, for different frequencies. So it was found that, let's say you've got a frequency here, F1, and what you're doing is you're reducing the voltage, you're getting the voltage smaller and smaller and smaller, and it's found that as the voltage gets smaller, the size of the current decreases, but even at 0 voltage, there's still some current. So you've got to make the voltage even smaller. This kind of follows on from here. What you're actually doing when I'm saying you're making the voltage smaller or making it negative is because you're giving the emitter plate a positive potential. So let's say that's for a particular frequency. And then you do the same thing for another color of light, so another frequency, and that would be very similar, but what you notice is the intercept on the x-axis is different, okay? And let's say you can have another one here. Okay, you've got different frequencies. So this tells you that even when the voltage is 0, there's some current, and the current becomes 0 only when the voltage is the voltage of the emitter plate is sufficiently positive. Now the intercept on the x-axis is actually the cutoff voltage. It's the voltage at which current becomes 0, okay? And it's found that the higher the frequency, the greater the cutoff voltage, because more the energy of the photoelectrons. Now one of the questions in your booklets has these frequencies at different sorts of amounts of current. It could be that when white light is used, in order to get different colors, you need filters. So when you put a filter in front of white light, some filters may actually change the intensity of light a little bit, so the intensity may not have been exactly the same for all the different colors, and that is why the current may have been affected, because the only thing that affects the current is the intensity of light. So I hope that made sense. So bye for now.